This video is discussing solving absolute values for both equations and inequalities. So first, I would like to go over the rules of absolute values. If I have a positive value inside of the absolute value bars, my output is going to be a positive number. Even if I have a negative value inside of my absolute values, it's still going to have an output of a positive number. So based off of the example that I have to the right of it, I show that it's no solution because it's showing me that this absolute value has an output of a negative number. Well, we know that's not true, again, based off of these rules over here. Both of my outputs should be positive. So let's just test it with any random number. Typically, students will see this and assume that, well, -3 will work because -3 plus -2 is -5. However, that -3 minus 2 is actually in a set of absolute values. So yes, it is -5. However, based off of my rule over here, if I have a negative value, my output should be a positive number. So therefore, this side is actually going to be a positive 5, whereas this side is a -5. So I know it doesn't work. Even if I used another value just to demonstrate it, it's not going to work as well. So in that case, the answer will be no solution. Now, what you'll notice is in example 1, there's some similarities between what I just talked about and what I'm about to talk about. The only difference is there's a negative sign out front. So if you ever have anything in front, after, or even below your absolute value, you want to get rid of that first. And then it's possible that you could have a negative output to start. So let's work through this and see how that looks. The first thing I want to do is get rid of that negative sign, which is really a -1. So I want to divide it because anytime you have things next to each other, that means multiply. So the inverse is to divide. So when I divide, it's going to get rid of that negative sign, and I'm left with the absolute value of the quantity of x minus 2 is equal to -5 divided by -1. Well, the negatives go away, and it's simply a 5. For an absolute value, you're going to have 2 equations or 2 inequalities. So what I want to do is once I get it to the point where the absolute value is isolated, I want to go ahead and set up my other equation. So I'm going to also have the absolute value of the quantity of x minus 2 is equal to, but this time I'm going to change the sign to -5. I'm going to solve both of these equations. And once again, as I isolate the absolute value, I can just drop the bars and solve for x. So this is going to be x minus 2 is equal to 5. And then I just want to add 2 on both sides because that's the inverse, and continue solving for x. So x in this case is going to equal 7. On the other side, what I want to do is drop the bars, and I'm left with x minus 2 is equal to -5. And again, I'm going to add 2 because it's currently a -2. So I want to make sure that I am doing the inverse. And I have x is equal to -3 this time. So if I wanted to test these values, what I would do is I would go back to my original and then substitute it in. And in this case, both of those do actually work. Let's go ahead and box those off. These are both of my answers for example 1. So let's go on to example 2. Example 2 is still an equation, but before I can create 2 separate equations, I need to isolate my absolute value. So let's think about this. You've done this before and maybe you just don't remember. Say for instance, you had an equation 2x minus 7 is equal to 19. The first thing you want to do is to isolate in order to isolate the x is to get rid of your constant. That's that number that's alone that doesn't have a variable next to it. So I want to combine them. So I'm moving it from one side to the other so that I can just slowly chip away and get that x by itself. And then what's the next thing that you would do? You would get rid of what's stopping x from being by itself, which is 2. So in this case, your answer would have been x is equal to 13. It's similar with absolute values. You have to first get rid of anything that is in front or behind, starting with the constant. So that's what we're going to get rid of first. The inverse of a -7 is a +7. So that goes away, and I'm left with 2 times the absolute value of the quantity of 3 minus 5x is equal to 26. I want to get rid of that 2 that's in front of the absolute value because I'm trying to isolate the absolute value. And I am left with the absolute value of 3 minus the quantity of 3 minus 5x is equal to 26 divided by 2, which is 13. So at this point, I have my absolute value by itself. It's isolated on one side. So I'm going to create another equation. The absolute value of 3 minus 5x is equal to, this time it's a negative 13. And then again, I'm going to solve for x. So I'm going to drop my bars. 3 minus 5x is equal to 13. I personally don't want my x to be negative, so I'm going to move it to the other side. So I'm going to have a positive 5x here and a positive 5x over here, since I can't combine it with the 13. And now I'm going to move that 13 over. Since it's already positive, I want to make it a negative. That's the inverse. So on both sides, I'm getting rid of something. Once I simplify, I have a negative 10 is equal to 5x. Well, what's stopping 5 from being by itself? I'm sorry, x from being by itself? 5. Now, if it bothers you that the x is on the right-hand side, just swap it around. So x is equal to negative 10 divided by 5, which is negative 2. And now we're going to go over to the other side and do the same thing. Drop the bars. And this time it's set equal to negative 13. Again, I want to add my 5x. You don't have to do it this way. You can actually move the 3 over if that's what you want to do. But I am going to this time add 13 because it's already a negative. I want to zero it out. And again, I'm getting rid of 2 things, one on one side, one on the other. 3 plus 13 is 16. Let me be consistent here. So 16 is equal to 5x. And what's stopping x from being by itself? It's that 5. So on this side, x is equal to a fraction, which is 16 over 5. And that's approximately, if you have to write it as a decimal, 3.2. I'm okay with leaving it as a fraction, but just for those people who wanted to know. And again, if you were to substitute this back in, you want to go back to your original problem. And it's telling you that once you substitute it in, it should equal 19 for both of those. Example 3 is now we're talking inequalities here. Same thing, you want to look to see if there's anything before, after, or below. It's not, so if it's already isolated, all I have to do is just go through and set up my other equation. So that's what I'm going to do. I'm just going to rewrite it below it so that I can show you. Let me see here. So absolute value of 9 minus 4, I'm writing the same thing, is less than or equal to 11 in one case. And then in the other case, the absolute value of 9 minus 4x. So the left-hand side still looks the same, but this time I'm going to flip this sign, greater than or equal to, and I'm also going to change the sign of my value, negative 11. Now I want to work through without the absolute value bars because it's already isolated. I can go ahead and drop them. 9 minus 4x is less than or equal to 11. And I'm going to do the same thing, start trying to dwindle away until I can get my x value by itself. And that is going to leave me with a negative 4x is less than or equal to 11 minus 9 is 2. And what's stopping x from being by itself? It's a negative 4. Now, pay attention to this because if you ever have a negative that you are dividing both sides by, you're going to have to flip your sign. That's just part of the rule. So this x now is no longer less than or equal to, it is greater than or equal to. And then once I simplify 2 divided by negative 4, I have negative 1/2 or negative 0.5 if you want to look at it as a decimal. Then going over to the other inequality, I can drop the bars. I have 9 minus 4x is greater than or equal to negative 11. And I'm going to do the same process. I'm going to subtract 9 on both sides. I have negative 4x is greater than or equal to negative 20. But this time I am dividing again by a negative number. And when I do that, what does that mean? Yep, got to flip the sign. So this time X is less than or equal to, and the two negatives go away. So 20 divided by 4 is simply 5. I'm not finished though, because what I have to do in the case of inequalities is I'm going to use notation format. So if you are a visual person like I am, I like to see what would this look like on a number line. So this is my number line. I know that negative 1/2 is somewhere over here. I'm just going to put a 0 right here. And then 5 is over to the right of 0. So I like to follow my arrows as best I can. Well, these look like arrows to me. So it's telling me that X is everything greater than negative 1/2, or meaning it's going to the right. So, and it also tells me greater than or equal to. That equal to means that I'm going to have a closed circle. So at negative 1/2, I have a closed circle. And I know, well, I'm not going to shade in anything else until I do the other side. So on the other side, I see at 5, it's still equal. So I'm going to have another closed circle. But this time the X is before 5. It's everything less than 5. So what that tells me is that X can be anything that's sandwiched in between those two values. So what your answer will look like, your final answer, is going to be, since they're closed circles, you're going to use a bracket, and you're going to have negative 1/2 first, and then you're going to have 5 second. This is your answer. That's a lot going on here. So let me kind of highlight that so you can see it. That's your final answer when you're using inequalities. Okay, last example. Let's say we had something that's greater than. I noticed that I also have my absolute value is already isolated, but I have a fraction in front of my X. So let's try to work with that. I'm going to drop my bars, and I'm going to write 2. We'll not drop them yet. 8 minus 2 over 3x is greater than 22. And then on the other side, I'm going to do 8 minus 2/3 x is less than, change the sign, negative 22. So not only are you switching the signs around, you're also changing the sign of the value that you're working with. Now I can drop my absolute value bars, and I'm left with 8 minus 2/3 x is greater than 22. And I want to subtract 8 on both sides, which leaves me with negative 2/3 x is greater than 14, 22 minus 8. Now, pay attention, because this is tricky. It can be if you're not paying attention to that. So I have a negative sign that I'm going to have to divide both sides by, which means I'm going to have to flip the sign. So I'm going to go ahead and flip the sign now so I don't forget. So it's no longer X is greater than, it's now X is less than. Wow, you're saying, well, there's a negative 2/3 there. Not for long. What I am going to do is I am going to multiply both sides by the reciprocal. What's the reciprocal? It means when you flip the numerator and the denominator of your fraction. So once you do that, you can just go ahead and cross that out, and you're left with just an X, because the numbers diagonally are the same, and you have one negative sign, so you can get rid of that with either of those numbers. But what you do to one side, you have to do to the other. So I have a negative 3/2. And I can either use my calculator and multiply across 14 times negative 3 divided by 2, or I can, what I typically do is just go ahead and get rid of the diagonal, simplify diagonally if I can. So what does that look like? 14 divided by 2, that's going to give me a 7. So 7 is going to be multiplied times what's left over, which is negative 3. So 7 times negative 3, I'm left with negative 21. So again, I am a visual person, so I'm going to go ahead and start a number line here. And it's saying, and again, I see this as an arrow, and I see X's are all the way over towards negative infinity, and the greatest number is negative 21. So all of these values can be X. That's what I see. Now, what I also see is there's not an equal sign under here this time. It's just simply less than. So X is all the values less than negative 21. So what that tells me is I'm now going to have an open circle. So let's go on over to the other side and we'll finish our inequalities number line after we solve for X. So I'm going to drop the bars and I have 8 minus 2 over 3x. This time is less than negative 22. I am going to subtract 8 on both sides because again, I'm doing the opposite sign, which is called the inverse. Take negative 2/3 x. It's less than, and when I simplify this, this is negative 30 this time. I want to use the same process. I have a negative sign that I'm about to divide by, so I want to flip the sign. Instead of less than, it's going to be greater than. I also want to multiply both sides by the negative reciprocal. Well, not the, so negative 3 over 2. That's going to get rid of the negative 2 and the positive 3s, if that's how you look at it. What you do to one side, you do to the other. Negative 3 divided by 2. And you can put it in the calculator as negative 30 times negative 3, all divided by 2, or the way that I do it. Negative 30 divided by 2 is negative 15, and negative 15 times negative 3 is a positive 45. So now I see that X is all the numbers that are bigger than 45. So bigger than 45 is going to the right. Again, it looks like an arrow to me. So I'm going to shade in everything to the right of 45 because all of those values can represent my X. I also notice this does not have an equal sign. So it's just simply greater than, not greater than or equal to, which means at 45, I have an open circle. Again, I want my actual answer to be in interval notation form. So looking at my graph, the way I would write this time is with parentheses because I have open circles. And I'm going from left to right. Let's go ahead and put that on there so you can see it. So negative infinity, and then it stops at 21, negative 21. There's a union, and it starts again from 45 to positive infinity. And that is my answer. So you've learned how to solve absolute values for both equations and inequalities, and I do have a graphing one coming up. Have a great day, subscribe, thumbs up.